Hello, everyone. I hope you are having a great time at the conference. And this is my second time speaking in a conference, so I may fumble a bit. Please pardon me. Today, I'm going to talk about a project which is very close to my heart because I was contributing a little bit to this project. And I feel like this is one of the projects which is not very known in the observability community. It's written by someone you might be familiar with, Kyle Kingsbury. He's known by his Twitter handle called Afire, and he writes a lot of blog on distributed systems. He built a tool called Jepsen. You might have read some blog about testing distributed systems using Jepsen. But this talk is about Riemann. It's a monitoring system written in a functional programming language called Clojure. Clojure is basically a functional programming language written on top of JVM because JVM has a really good garbage collection and all the lower level stuff. So today we are going to see how we can leverage functional programming concepts in a monitoring system and do things a bit differently. Hopefully you will learn something out of this talk. I would like to start with some basic introduction about Riemann. Riemann is basically an event processing system designed specifically for a domain, which is metrics. One of the cool features about Riemann is its configuration is actually a Clojure code rather than YAML or JSON. We will see how that actually is a bit advantages over rest of the monitoring solutions we have in the open source in coming slides. Riemann is basically built on top of solid ecosystem of Netty and protobuf. If you're not familiar with Netty, Netty is a framework for building asynchronous, event-driven, fast network communication framework. And protobuf, you would already know, basically it's a data serialization format. So one thing about Riemann is it's completely stateless. It doesn't store the events. It's basically a processing system. You can consider it something like Logstash or Vector, which is really famous nowadays. So if you need any kind of persistence, you need to use third-party time series databases like InfluxDB, OpenTSDB, Graphite, or like anything you can think of. It's very simple to add as support for any of the third-party databases. It has a very good support for mutual TLS. Mutual TLS is basically using the same certificate-based authentication mechanism between server and client. Now that we have looked at a bit about introduction about Riemann, let's look at few concepts. There are three important concepts: an event, index, and a stream. So you can think like every host is sending a stream of events. An event is basically like some monitoring system call it data points. You can think it as a signal which shows that something has changed in the system. And stream is basically collection of all those events which is flowing together from source to destination. And an index is basically a snapshot of all the most recent events in memory of the Riemann process. So basically, this diagram, you can get an idea that streams are flowing into Riemann, and then you can basically do some kind of computation. And then you can actually ship it to wherever you want to do. Let's look at what a Riemann event looks like. This is basically a Clojure map. Out of these fields, these fields are very common in any monitoring system. I would like to talk a bit about description. Description is basically what that metrics talks about. But you can use this description field, like let's say, if an exception happens in the Java application or stack trace comes, you can actually append the whole stack trace in the description. So that way, you can add some metadata about the event. One another thing which is very different in Riemann is the TTL field. Riemann is built with the concept that every event has a expiry time. So this TTL actually says like how long from the occurrence of the event that event will be valid for. So in this case, let's say at the time Unix timestamp this event happened, it will actually be valid for 10 seconds from that. This event basically is now converted into protobuf before sending from the client to the Riemann server. Let's look a bit about the Riemann index. Index is basically using a Java concurrent hash map implementation, which is lock-free and non-blocking. It's completely in memory. It only stores the most recent events for a pair of host and service. So the ID of this hash map is host and service tuple, and the value is the complete rest of the fields in the event stays, as I mentioned earlier, event stays in the index up to the time TTL value. After that, they are converted into expired events, and we'll look how that actually helps in Riemann ecosystem. And there is a Riemann dashboard. It's very basic, but it basically talks to Riemann over WebSockets, and it displays the data of the Riemann index into a dashboard. Let's look at Riemann stream. Riemann streams are basically closure functions, which takes an event and basically do some operations on those events. A stream can actually give rise to multiple child streams. So all these child streams are also functions. Now, it's basically down the, if you look inside, it's just basically a function calling another function, passing the events. And this has some inherent advantage because when a function calls another function, it's in the program stack. So everything happens very fast. Also, like JVM does some kind of optimizations, like inlining the function calls, those kinds of things. So these actually help in making Riemann to consume the stream very fast. Now, stream is one of the most powerful abstraction, I would say. You can do anything what you can think of. You can filter events. You can actually split an event stream into multiple streams. You can combine multiple streams into one. And whatever you can think of, it's up to your ability. Right? Let's look at very basic example. In the top, we are having a stream, and we are just printing it to std out. It's printing the event into the std out of the process. Let's look at a filter example. Basically, in this case, we are using the where function because functions are streams. So I will use the term function or stream interchangeably. So we are using the where stream to basically filter events which are matching service name starting from Postgres and state as critical. So you can see in the diagram, let's say 4 events are coming. The events which are not matching are thrown, and the events which matches both the criteria are now passed, and then they are emailed. If we look at the where stream, it accepts a predicate, and it can accept any number of child streams. Like we say, like the predicate here is like matching the service name, and the child stream is like email. Similarly, here in the second example, the child stream is sending email as well as sending a Slack message. So you can basically build a whole pipeline just by writing closure code. Another thing very interesting is like, let's say we need to split a stream. This example shows how you can take a stream and split it across so that all the events now goes to both of the streams. This is a basic example of merging multiple streams. Let's say you have stream coming from multiple hosts in your data center, and we need to compute how many hosts are sending the Riemann streams. So this is just a basic example how you can use the coalesce and streaming map to combine all those events and get the count of the number of unique hosts in the data center. Now that we have looked a bit about stream, let's look how you can send data to Riemann. Riemann basically has each per language client libraries. You can use those client libraries directly within your applications. This is an example where the Python client library is sending an event to Riemann, and then we are using the client library to query the index and printing the event. Apart from that, there are all the open source tools which are responsible for metric collection. Like you would have definitely used one of these at least, collectd, logstash, syslog-ng. They all support sending events to Riemann. You might be thinking, why syslog-ng? Syslog-ng is a log shipper agent, but many a times you would need scenarios like you want to count number of exception happened in the logs. So you can basically specify a regex of the exception, and then you can, whenever that regex matches, it can send event to Riemann. If there is one thing which I would like you to take away from this presentation is the Riemann configuration, which is the most unique thing about the whole project. As I mentioned before, Riemann configuration is a closure code. And the benefit of this is now you can leverage all the language capabilities to basically write small testable and reusable pieces of code. You can actually build libraries which you can actually give to your rest of the engineering teams. So they don't need to know how to implement something. They can just call your function, and let's say they want to know when a service goes down. I would like to take a step back, and I know everybody must be familiar with Prometheus, and at Cloudflare we use Prometheus a lot. And I would like to show you an example how different team writes different alert expression for same Prometheus. So this is a Prometheus alert expression written by 3 different teams. And if you see, all the three are trying to do the same thing when their service is down, but they all are writing it in a different format. In my opinion, the first one is the most accurate, so you can see there is a divergence in the configuration. But if you are using something like Riemann, and you can expose these things to the engineering team, like, is my service up? And they can just pass the service name, and they don't need to care whether I need to check whether the time series is available, or whether the up matrix is 1 or less than 1, or what should be the value. As an engineer, I don't want to know everything about how the monitoring system is working internally. So this is one of the good point I like about Riemann. Another thing is you can organize your configuration better. Like, because it's now a closure code, you can divide the code into closure namespaces. So in this, like, we are writing a library like around the infrastructure-related alerts, and this is under a namespace. You can see the namespace macro in the top, and you can call this library from your Riemann config. So this way you can basically organize your code better. Another very interesting thing is how you test your configuration for your monitoring system. Because now it's a closure code, now you can write unit test, integration test in closure. And Riemann also provides a concept of tap. Tap is like a breakpoint. Like if you use GDB or any kind of debugging tool, you add a breakpoint. It's something similar in a Riemann stream. So you can add a tap where you want to observe how the stream looks like at this point of the stream. You can see an example on the top left. We are defining a stream, and in that, after doing a filtering and appending a state OK, we are tapping the stream. Now, if you need to write a test for this, on the right side, you can see that what we are doing is we are injecting a test event into the stream with host, service, and metric keys. And once it comes out of the tap, it should have that state OK, which we are appending in the stream as per the configuration. So you can see on the test case, we are expecting state OK. And on the bottom left side, you can see we can just run Riemann test, Riemann.conf. So basically, you can test these things in your CI/CD pipelines before it reaches production. Now let's look at how you can do the usual monitoring, which you need to do in your day-to-day life with Riemann. Let's say you need to know when a service has gone down. In Prometheus, as you know, like you generally have an up metric whose value is 0 or 1. But in Riemann does things a bit differently. In Riemann, there is as you noticed before, there is a TTL value associated with each event. And as soon as the event expires, the event is taken out of the index and is basically the state is changed to expired, and it's re-injected into the index. So if you notice in your stream that for a particular host and service pair, the event has expired state, that means that that application is probably not working well. When things break really badly, we get flood of events, we get flood of alerts. How Riemann does handle these things is Riemann provides you special streams like rollup. Rollup basically is like, I want to get alert for the first few instances of the event directly, but I don't want to get notification for each of the instance. So in this case, if you notice, like we are doing rollup 3600, that means we will get page for the first 2 events directly. But for the third page, it will wait for the next 3600 seconds for 1 hour. And at the end of the 1 hour, basically, it will take all the events and send it in one page. So this way, it will not flood you with notifications. This has a downside because now Riemann needs to keep all these events in memory. That can basically lead to unbounded memory usage, and it can lead to out-of-memory situations. So Riemann provides another stream called throttle. Throttle, as the name suggests, you basically drop all the events after certain number of events. This is also you would not like to use in production because you don't want to drop events randomly. So you can actually use a middle ground of rollup and throttle. And you can write something like throttle 30 events, but rollup on 3 events. That means the memory usage will not go unbounded. It will still remain bounded, but we will not lose the initial 30 events. This is one of the power of Riemann. Like you can compose things in the stream very well. Another thing is, how do you scale Riemann? Riemann is a single binary. It runs a single process. It doesn't have anything like sharding or like distributed setup. It's a single thing. But Riemann provides you some functions or streams, basically, to build some kind of scaling. Riemann has something called forward stream. In this example, you can see that this Riemann instance is actually forwarding the events to another remote Riemann instance. This way, let's say you can shard all your front-end events to one Riemann instance and all your back-end events to another Riemann instance, and then you can merge both of those streams together. You can do as you would like as using this forward stream. But there is one flaw with this. The problem is Riemann streams are synchronous. That means it will wait for a response from the upstream server before it sends response to the client. In this case, let's say when the client sends the event, the client will not receive success until it receives the acknowledgement from the upstream server. So this is when you can actually do async streams. There are two ways to do these things. You can build async queue. Async queue is like a bounded queue, which you can use. All the events in the async queue will be processed by a separate thread pool. This way, you can make sure that your responses go immediately to the client. One of the problems with async queue is since it's a bounded queue, then you can actually end up filling that queue and Riemann will drop those events. In that case, you would like to use something like on-disk based queuing system like Kafka. Riemann supports Kafka. It supports producing and consuming from Kafka both. So you can use Kafka plugin. Also, many times, let's say you are talking to some third database, like let's say InfluxDB. You would not like to inject an event for every event to InfluxDB. You would like to batch things and write in a batch. Most of these analytical database perform well when you are writing in a batches. So for that, you can use batch stream. You can batch, let's say, I want to batch 1,000 events or all the events which has accumulated over 1 second. Like you can batch on those 2 parameters. In this example, you can see we are using async queue and batch together to basically talk to some downstream service. Like it can be InfluxDB or anything you can think of. With that, I think my talk finishes here. I would hopefully you learned something from this talk. If you would like to try it out, Riemann, it's available in this website. Thank you.
We still have a bit more time left for questions. Are there any?
Pradeep, thanks a lot for your great presentation. It was very useful. I have 2 questions. One is, you mentioned about it supports a lot of time series databases like InfluxDB.
Right.
Sounds good, but my personal experience is InfluxDB is open source as long as you have a standalone and you wanted to cluster it, it's going to be an enterprise. Right. So my question is, do you think this supports any other time series database like TimescaleDB, which is purely open source, or Druid, for example?
Yes, they have support for Druid. You can write to OpenTSDB, ClickHouse, Graphite. Like, it's actually very simple to build a plugin because basically the plugin does nothing. It takes this event and it just because batching and all those are provided by Riemann internally. So you don't need to think about that. You just need to create an array and you need to just push it to the third-party database. So it's very simple to add. I think TimescaleDB support is not there, but Druid and then Prometheus, all these supports are there.
The second question is, you also mentioned that supports dashboarding and things like that.
Right.
Can I connect directly from any of the visualization tools?
Right.
Grafana, for example, Superset, for example.
Right.
Is it possible with that?
Yes. I think somebody wrote the Grafana data source plugin. I haven't tried it, but it's definitely there. I don't know about Metabase or Superset if they have, but yes, Grafana definitely we can support.
Thank you.
Thank you.
Great talk, thank you. Are there any plans to create a configuration UI for Riemann so that users could configure those rules by pointing and clicking?
That's a great question. I don't think so. But probably somebody might have done something around it. But I'm not familiar with it because it's very popular among the functional programmers. So that's why it's a bit easier. But for a non-functional programmer, like it's definitely very difficult. Yeah, that's a great idea actually.
One more question. You talked about graphing backend stores. Is there some kind of back pressure mechanism? So because Riemann is very fast, and if the grapher isn't able to take up, can you like stop the inputs or something like that?
Yes, because Riemann streams are synchronous. Because of the synchronous nature, you can actually put the back pressure implement, like that is there inbuilt in Riemann. If you use async queue, then back pressure won't be available. Right.
Great, thank you.
Thank you.
So, thank you yet again, Pradeep
you.
Chhetri.
Thank you.
Yourself open it for me. Yourself open it for me.